Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken and Seth's brother Joel. We're here to hopefully help you go over ways to approach SAT math questions, if not all questions. This is question 10 of 16 questions that the SAT distributed in their pamphlet, which helps you prepare for the digital math SAT, which starts in the United States in winter of 2024. Okay, which expression is equivalent to this? And they give you these choices. So please stop the video, do it, come back. Looks to me like there's no pattern. I mean, other than this is not the answer. You have to use a common denominator. This does not look like the answer. Or virtually impossible. And
Well, it certainly isn't,
yeah,
because for very, very large X, the left-hand term is approximately 1. No, sorry. The left-hand term behaves like 1 over X for very large X.
okay.
And the right-hand term behaves like 1 over X for very large X. And we subtract them. And so whatever the answer is, it has an X squared. Whatever the answer is, these 1 over X's cancel. And so it can't be B.
Okay, well, nobody's going to think that way.
Nobody, well, some people have gone a bit further in math than their grade level, and they'll see that. But
Oops, we just lost.
Joel's point is that
you erased something. You just lost.
I know, I fixed it. But that method is you can't expect people to use that method.
Also, that's not going to get to the answer. Looks to me like you have to use brute force. You just have to add the fractions to the common denominator.
All right.
It seems to be that seems to be the right now. It seems to be
all right, and adding so let's do adding the fractions.
So normally we'll go back and do it the way you normally do it, but you could sort of take a chance and cut corners, I guess, and do 4x plus 1 minus 4x minus 5. Being really careful about the parentheses. And later show how do you do that. So the 4x is you could do this in your head, but it's not advised. There's an approach thing. Not advised. You cross these out and you get 6. 4. You get 6. Wait, but that's not one of the answers. What's going on?
Oh, what
because what's going on? What did I do wrong? I distributed wrong. Oh God! Oh yeah, everybody does that.
Yeah.
Well, I was lucky. Oh my God! I can't believe they didn't put a 6 down there. It's 4 plus 5. Oh, I made the mistake everybody makes. Thank you.
Yeah.
Oh God! Why didn't they put a 6 there? That's so strange. 1 minus. That's so strange. Why didn't they put a 6? They should have put a 6. And it was just to really snag people like me, which is the most common mistake. Wow. So it's 9. So it's this one. It's my board froze, but it's A. Wow. Boy, we're real lucky.
Okay.
This is the second question in a row I got wrong. And I got right because they didn't think anyone would be stupid enough to do that. But hey, a lot of people are stupid enough to do that.
4 minus 4 plus 5. Yeah. Okay.
Yeah, 4 plus 5,
yeah. What I would, here's how I would do it with my eyes. I would see the 1, and the 1 gets multiplied by the 4.
Right.
You get 4. And then I see the minus 5. And the minus 5 gets multiplied by the minus 1.
Yeah.
To get 5. 5 plus 4 equals 9.
Right.
Now, should we show people, I want to show people why this works.
Yes, we have to show people why it works.
Okay, so let me do that. You take the original problem and what's called put the form the fractions so that they have a common denominator.
Yeah, what I'm going to do is I'm going to try to
And the
erase.
easiest way to get a common denominator for two fractions is to take the common denominator to be the product of the two denominators.
Right.
And so what we do is you take your 4 over 4x minus 5, and your minus 1 divided by x plus 1. You multiply the top and the bottom by the other denominator. And then multiply the top and the bottom of the second term by the other denominator of the second term. And then we see that the common denominator is the product of the two original denominators.
Right.
And so this one has that form, this one has this form, and this one has that form.
Right.
The product of the two original denominators appears in the denominator of 3 of the choices, and you just have to figure out the numerator is. You could see that all 3 have coefficient 0 for x, so don't bother working out the coefficient of x, but just look at the constant coefficient. The constant coefficient is 4 times 1 from here, and plus minus 1 times minus 5 from here. They get added. There's the 4 and the 5. I got the 4 and the 5 that I got before. And 4 plus 5 equals 9. And you pick.
Right.
So you pick this one with the 9.
Yeah, it's very, very good when you're adding fractions to do this little thing that Seth did. Right?
Yeah. Now that's the standard algorithm that they teach.
Yeah. But
it's like if you're adding, what is 1/3 plus 1/7?
Yeah.
Yeah. That is 7. So multiply the same thing. You multiply this by 7 over 7, and this by 3 over 3.
Right.
And you get 7 plus 3 equals 10 over 21.
Right, exactly.
Now, in grade school, they teach you to find a least common denominator, which is okay to do if the fractions are numerical. But in the case of polynomials, it's harder to factor polynomials, so why bother with looking for a least common denominator? You just take the product of 2 of them, the 2 denominators, and you get a common denominator. It doesn't matter whether or not it's least, and that gives you the method.
Absolutely right.
So, for example, if you had, like 1/2 plus 1/4, right? A least common denominator is 4. So kids are taught to convert the half to 2/4 and add it to 1/4 to get 3/4. But you could also do it by forming the common denominator of 8.
Yeah.
2 times 4 is 8 divided by 2 plus 4. And so we get 6 divided by...
Are you writing?
6 divided by 8, which is also 3/4. Then get rid of the common factor later.
Right.
This is, cancel out the 2s, and you get 3/4.
Right. Yeah. It's all, absolutely right. I cut corners here because many people would, but I paid for it. If I slow down a little bit, I may have caught this mistake. But I still can't believe they put a 6 there. They assumed here that you would make a mistake with the negative sign, which is the most common mistake in algebra,
Yeah.
is not distributing this negative sign. This is the most common mistake. But I still can't believe they didn't assume people would do what I did. Let's be honest. Oh, Seth, so you were honest. So if you did this problem yourself, you would have just done it the way you did it, right?
Yeah, sure.
Yeah. And I probably would have done it this way. So anyway, that's how you approach these problems. But it looks to me,
the thing is, I would do it this way, except that I instead of writing 4 times x plus 1, I would imagine it.
wow.
And I'd see 4, and then I have to be careful to use the minus 1. 4x minus 5 times minus 1, and then I'd realize that I'm interested only in the constant coefficient, so I'd ignore the x, and I'd say 4. So I use my eyes, as I said. I take the x.
No, you said already. You don't have to say it again, Seth. You already said it again. Let me ask you another question though, before we go on to Throwback Thursday. If you did it on your eye, would you have redone it in your eye to check before moving on? Or would you have said, I'm done, I'm out of here, goodbye? Or
I would recheck it with my eye.
So you would have done it twice.
Yeah, I think so.
Yeah, well, that's a very important approach. Hopefully everyone will
however, the other approach to check it is to substitute x for 0.
Oh, yeah. In other words, Seth's saying something which I've noticed also, that this is always true. If this is always true, always, like always, okay? So it's for all x. So if you just throw x 0 in there, then what is that? That's 4 over
no
negative
problem.
5.
It's okay. It's legal.
Minus 1, 4 over negative 5 over 1. That's a minus 1, right?
Minus 4/5.
Yeah,
plus 1.
Minus. Plus 1, right? Yeah.
Yeah,
but nobody's Nobody's.
No.
Okay, but you could, if you have an infinite amount of time, you could. So you can see which one is true when x is equal to 0. Okay, ready for Throwback Thursday. So Throwback Thursday, we go back a test from maybe 20 years ago to highlight the difference between the nature of the tests that were given 20 years ago and the tests that were changed in nature in 2016. Back then, the tests were more reasoning, and they were mostly more reasoning. They certainly had math on it, but it was more of a reasoning test. Still had to know some math. And somewhere here is our Throwback Thursday question, which is now currently lost. Oh, yeah. Should we just give a quick look at their answer? How did they say to do it? To subtract one rational expression from another. Ooh, they use fancy words, rational expression. The denominators of the expressions must be the same. Since that. I don't think it's worth reading. We have to find the solution.
It's not explained very well. You could subtract one you could have 2 rational expressions with different denominators, and you can subtract them. And that they do is they explain how. It's ridiculous. The truth is that it is simpler to subtract 2 rational expressions when the denominators are the same.
Okay.
And when the denominators are the same, you subtract them by subtracting the numerators.
Okay.
But when the denominators are not the same, then the answer is not gotten by subtracting the numerators. And so what you do is you transform them. You transform the 2 fractions into fractions where the denominators are the same. And then you could subtract the numerators.
I love when Seth gets upset. Okay, so their answer, though, followed really what we did. Yeah. Except they wrote everything out. It's not a bad idea when you approach these problems not to cut corners and to write everything out. It's highly advised.
Yeah. But again, if you, it's a good idea. If you're say if you're playing a sports game, right? Why not run as fast as you can? The game. If you could run the bases faster, you do it.
Right.
Yeah,
Yeah.
yeah. So you do your exercises of adding and subtracting rational expressions.
Yeah.
After you get the idea to do every step, you could then do them faster and faster and do more and more of the steps in your head.
Hmm. Okay,
And
moving to Throwback Thursday. Here we have a question from a test from 20 years ago. Let's see. You can read it, stop it. Looks very different from anything in the post 2016 test, but it may be easier than it looks. It may actually be a very easy question. Let's see. There are 5 houses on each side of the street, as shown above. No 2 houses next to each other on the same side of the street, and no 2 houses directly across from each other on opposite sides of the street can be painted the same color. Seth, this is up to you. This is like the math question.
Yeah.
Oh, Seth feels right. This is his PhD is in this type of stuff. If the houses labeled G are gray, then how many of the 7 remaining houses cannot be gray? Oh, so no 2 houses.
That's easy.
Wait, so
you just go over the houses and you mark the ones that cannot be painted gray.
So this can't be gray.
And you count
and this
them.
Can't be gray. Right? And this can't be gray. And this can't be gray. And this can't be gray. What am I doing? This can't.
Yeah.
Oh, wait. This can't be gray. Oh, so only one? But that's not.
Only one can be painted gray, but they ask for how many cannot. So you count your green crosses.
Oh, so let's put in, just to be cute, let's put in a gray here, okay? Let's put in a gray.
2, 3, 4, 5, 6.
How many houses cannot be painted gray?
The answer is 6.
Oh, so the answer is 6. Okay.
You count the gray. A good idea to count the green crosses because it asks you how many cannot.
Right.
Not how many can.
Right. So I almost made that. So they didn't put a 1 there? Oh, wait.
Nope.
Wait. No, but
they didn't put a 1 there. They should have put a 1 there because a lot of people would have got the wrong answer.
I want a streak today. No, I would have read the question carefully before I answered it. I would have said 1, and then I would have gone back and said, what are they asking?
Yeah, they made it easier by leaving out 1 for a distractor.
Right, but the answer could also have been 4, because how many? No, and the thing is, how many houses could be painted gray? The answer is actually 4, because you got 3 grays plus 1, or gray, right? Gray. So
they are painted gray, yeah.
Yeah. So it comes down to how many.
This present tense, they're currently gray.
Yeah. So So wow. Yeah. Boy, it's dangerous. I can't say for sure whether I would have gotten that right if they put a 1 there. I may have misread the question. Yeah. Oh, this is so.
Yeah, so we might have. Let's see, 4. Yeah.
How many 7 or 8 cannot be granted? So they made the question easier. No. Yeah, they didn't put a 1 there. Wow.
Oh well, can be gray. How many how is the maximum number that can be gray? You can add 1 more and get yeah.
Okay. So, but anyway, this question so clearly is no. This type of question would not appear on a post 2016 test. I mean, there's more reasoning than anything in here. There's no advanced math. There's no algebra. There's no geometry.
Yeah.
It's just reasoning. So this was there were a bunch of these questions on the tests before 2016. They changed the tests. What they're going to do now, we don't know. I mean, it looks like they're going to add a little bit more detailed calculations to the digital SAT because we just did a question which was full-blown 2 equation 2 unknown, which we also haven't seen recently. You can watch our older videos to see what they on this practice questions. There was a full-blown 2 equation 2 unknown problem, which we also never saw on the post 2016 test. So these digital tests may be a little different. They'll probably have a different feel to them. Of course, 2 years from now, we don't know the feel's going to be, but it feels like they're going to have a different feel. So, but they're probably going to be more like the 2016 test as opposed to this test. They're probably not going to go back to this reasoning stuff. So I guess that's it, right?
That's right.
Okay. Well, have a great day, everyone. Hope you got something out of today. Please like us, dislike us, give us comments. Please email us your SAT math questions at satmathquestionoftheday@gmail.com. And we hope to see you tomorrow. Take care, everyone.